Assalamu alaikum dear students. Today we will learn about the second classification of carbohydrates. The second classification of carbohydrates is oligosaccharides. It consists of short chain of monosaccharide units joined by characteristics linkage called glucoside bond. Here you can see two units of glucose combined together to form maltose. Likewise, we have another example of lactose, sucrose, etc. In this second classification of carbohydrates, you will see two important terms called acetal and hemiacetal. In the acetal, you will see the central carbon atom is attached to OR. R stands for alkyl group, and here alkyl group, and here you can see two OR and one alkyl group and one H group. You will see here. And if we see another example of acetal, you see here we have derived another example from this. Example is from aldehyde, and this example is derived from ketone. Here you can see the central carbon atom is attached to two OR and two R. So the necessary thing is that central carbon atom should be attached to two OR. You can see here. As you can see in the definition, a group of atoms that is represented by the central carbon atom bonded to two OR, one R and an H. If we have derived the example from aldehyde, you will see one H. And if we derive the example from a ketone, here you can see an alkyl group. And here you can see hemiacetal. In the hemiacetal, you will see here a group of atoms composed of central carbon atom bonded to four groups. One OR group, one OH group, one R group and an H group. If we are taking the example of aldehyde, here you can see this one is a central atom. It is attached to one OR, one OH, R and H. And if we have derived the same thing from a ketone, here you can see the central atom is attached to OR, OH, R and R. Now we can see the explanation of acetal and hemiacetal in the formation of maltose. Here you can see in the formation of maltose, one alpha glucose, alpha D glucose combines with beta D glucose. As I have explained you earlier, if this OH and this OH group, they are opposite in direction, then we term it as alpha glucose. And if we see here we have beta glucose. Why we call this beta glucose? Because this OH and this OH, they are in the same direction. When we combine these two glucose molecules, means alpha glucose and beta glucose, the phenomena is called condensation reaction. Now you can see here alpha glucose. In alpha glucose, you can see this carbon atom is attached to 4 other groups. This one is O, R, R, H, OH. Just like if you see here in the hemiacetal, the central carbon atom is attached to here one OR, one R, OH and H. You can see the same thing here. One OR, one R, H and OH. That's why this one is called hemiacetal. When alpha glucose combines with beta glucose, the reaction is called condensation reaction. In the condensation reaction, water is eliminated. Here you can see OH from here and H from here, they combine together to form water. Here you can see the water is released. So here we get maltose. The reverse of this reaction is called hydrolysis. The hydrolysis of maltose produces alpha D-glucose and beta D-glucose. As I have explained in yesterday lecture, some sugars are termed as reducing sugars and some are termed as non-reducing sugar. So by this lecture, the concept will become more and more clear. If a sugar, any sugar containing a hemiacetal is a reducing sugar. Likewise, if you see here, this one is the central atom, one OH, one OR, one R alkyl group and one H. This one is hemiacetal. And if this hemiacetal is derived from an aldehyde, you will see this type of structure. And if the hemiacetal is derived from a ketone, you will see such type of the structure. If you see the example of alpha D-glucose, whether it is a reducing sugar or a non-reducing sugar. So first of all, we will see if it contains hemiacetal, then it is termed as a reducing sugar. If you see here, this one is the carbon, it is attached to one OR, one R, one OH and one H. So this is hemiacetal. So that's why it is called a reducing sugar. If you see the example of D-fructose, here you can see it also contains hemiacetal. So this is also termed as reducing sugar. If we see the example of non-reducing sugar, here you can see a sugar without hemiacetal is a non-reducing sugar. So it means if a sugar is without hemiacetal group, so it is termed as non-reducing sugar. Here you can see acetal. Here you can see also the acetal. Here you can also see the acetal. Why it is important? Because this test for quantifying blood glucose. By this test you can determine the amount of sugar in the blood. So in the next video your concept will become more clear about reducing sugar and non-reducing sugar. So please have a look at the following video. So this one is the summary of monosaccharides and disaccharides. Please have a look at the following points. So this is all about our today's lecture. If you have any question, please ask. Jazakallah khair.